Hello everyone. Today I'm going to record the solution for homework D.6-1. Okay, so here we have parabolic semi-segment where we need to calculate the product of inertia IXY. As we can see in the picture, this parabolic semi-segment is described by this equation, h times 1 minus x squared over b squared. The base is b, the height is h. The best thing to do in this case is to find this differential area segment, which would be the y, that would be the variable y across the whole curve, times the differential x, that is a minimal unit x. And we can see that here. So let me put it down here. That's good. All right. And let's continue. So we know that the equation of the parabola is h times 1 minus x squared over b squared. So we need to replace that instead of the y in this equation, so we can find that. Okay, so let's define what we have then. Okay. So I don't know why there was this. Okay, it just looked a little bit funky. That's why I changed it again. So as we can see here, the equation of the parabola is this, and now we replace this y instead of in this equation, and now we have the differential area A dA is equal to h times 1 minus x squared over b squared times dx. Okay, we need to find the differential moment, the product of inertia element with respect to the xy axis, and after do the parallel axis shift theorem to change it to where the problem wants us to do it. All right, so we have these two distances, which would be x and y over 2. Yx because that's where the segment is located, x coordinates from the origin, and y over 2 because the height is y, right? And y over 2 would be the height to the centroid. We assume that it's just x because this is so negligible that it shouldn't be. It would be really, really small. Okay, so now what we do is to replace all of this equation into well, add the parallel axis shift to this equation that we have here. In order to do that, we're just going to do the following. We apply to the parallel axis shift to this. We know that the moment of inertia of this element with respect to the centroid of the element would be 0. The product of inertia with respect to the centroid would be 0. Sorry about that. And now we have the dA here times d1 and d2. Why do we use dA instead of a? Because we're talking about this differential area segment and not about the whole area of the parabolic segment. So now we have y dx times x times y over 2 that come from here. Okay, and we need to get rid of the dx. In order to do that, we need to integrate across the whole curve. Okay, and now we're going to do that. That would be our next step. When we do the integration, we just need to be careful. We can use substitution to do all of this process. We're going to find that the product of inertia about the origin for this parabolic section would be b squared times h squared over 12. Okay? Anyways, this would be the solution for this problem. Thank you for listening.